Hey Harbor Freight fans, quiz time. What's about, yay big, weighs about 25 pounds, has absolutely zero power, and punches way above its weight class in the ungodly racket department? No, not that, you jerks. This. You need ear protection within 5 feet of this puppy if OSHA's to be believed. Remember, with loud noises, the poison is in the dose. And by the time this thing's fully charged, your fillings will have been rattling for, let's find out. Let's be kind, let's give it 3 minutes. That's over 3 minutes to huff and puff enough air into the tank to fill one medium-sized tire. And that's fine, you say. Its only job is to fill up tires, but it's already slowing down here. Yeah, we're not going to make it. If you got 4 flat tires, there's no way you're making kickoff, go birds, and by the time you're done, your ears are going to be ringing and that sound is all you're ever going to hear. Come on!
Are you sure it's on? I can't hear a thing.
It's whisper quiet!
I'm being a little too harsh on Harbor Freight, as per usual. Relativism is important. I got this for Christmas like 8 years ago. It was $30 brand new, and to this day, it still technically works. It's just that all oilless compressors are destined for a drawn-out linear march towards a noisy death from the day they're born. It's like running a two-stroke on straight gas. It will run for a while, but with no dinosaur blood, synthetic or otherwise. It's a slow decline from a high compression piston down to a hot dog down a hallway. But check the old girl out now. It charges faster, and it's only as noisy as the trash pick refrigerator I got the parts from. Here's how to make your own, the cheap and easy way. To start, you need a junk fridge or freezer. How you handle the Freon, that's between you and God. Like any motor swap, there's no replacement for displacement, and bigger is better. This one's mid-sized, like a Ford 302 or a 327 Chevy. I'd like a big block, of course, but this is what I've got in the scrap pile. And at least I know it won't pop a 15 amp 120 volt breaker. Europeans be like, what? Laugh it up, Hans, we may not have universal 220. But suck it, because we have the Baconator. It's also nice because the entire refrigeration system, save for the evaporator, is all located on this service shelf. You got your compressor, your start electronics, caps and relays and such. You got your wiring here, which is great. That'll save a lot of troubleshooting. Plus some extra stuff like your filter dryer, your condenser, and your condenser fan, all of which we're going to be removing to make room for the tank. Everything we need on one convenient platform. Some more residential grade freezers might not have all these components packaged all nicely like that, but they're all there, and if you can get them all together, it'll save you all the custom wiring and difficult electrical crap. There is absolutely nothing like a frozen peanut butter cup after a long, hard day, and I'd like to thank Hershey's for this. They're not a sponsor or anything, I'm just fishing for some free peanut butter cups. If your stuff didn't come on a nice base like this, just make one out of wood or something. It doesn't matter. There are plenty of videos of industrious third world weekend tinkerers building fridge-powered air compressors like this, out of old fire extinguisher tanks and all kinds of cool stuff. But our economy is different, and building a refrigerator-powered air compressor from scratch here is going to cost way more time and money than a decent store-bought Harbor Freight compressor. Made in a factory, probably by the same guys that are making those cool YouTube videos. Building one of these things purely from scratch just ain't worth it, unless it's for funsies. And there's just too many nickel and dime parts you're going to have to source. But think about it. We've got a good tank right here, perfectly good pressure switch. We got fittings that work great. We got a regulator and 2 gauges already installed. Got a little check valve right in the tank. We have the safety pop-off valve here. Even the water drain down below. Everything. Except balls. You just need to identify the hot, neutral, and ground wires that ran your old fridge. This one has a handy connector, making it real easy. Easy as that. Purrs like a kitten. So we plumb that discharge port onto the check valve on the tank and splice the hot, neutral, and ground wires that fed this little turd nugget onto our fridge's cat box.
Is that it? Yep. Well, how hard can that be?
Well, there's a little more to it. Any HVAC techs who saw me running the compressor open to atmosphere like that are probably shaking their heads. Here's the challenge of using a compressor designed for a refrigeration system, and why it's not such a common upgrade. It's the oil. This design is going to present 2 oil-related design challenges. Firstly, since the Freon also contains the special oil needed to keep these sorts of compressors lubricated as they run in a closed system, no Freon in an open system like this means eventually no lubrication. You could just add oil from time to time, but with the polyester, the POE oil used with refrigerants like this, it turns acidic when exposed to humid, moisture-laden air. And it also smells like shit. Which is a problem because over time it's going to burp out of the outlet into your air tools. Solution? I'm going to flush the refrigeration oil out and replace it with plain Jane air compressor oil from the Hazard Fart. First, we need to dump the oil out so we can get a rough measurement of the volume of oil she needs. Ow. If you're not a trained HVAC tech or electrician, don't be an idiot. Take a good picture of how the wiring is supposed to look. Save yourself a lot of frantic, panicked Googling later on. The oil is going to drain out of the suction port or the service port. The suction port is the fatter of the 2 sides of the compressor. The service port is the 3rd side that goes nowhere but to a stubbed out service fitting. I cut the fat suction side because it's also going to be my air intake later, and more flow is more better. Rock it around a couple times because just when you think it's done, you'll get another spurt of oil out. "300 milliliters. So dump the oil into your waste oil container. Or your neighbor's garden. That'll show her for letting her little piece of shit dog crap in your Pachysandra, Roberta. They make specialty HVAC flushing liquids to get all the residuals out, but they're expensive, hard to find locally for the layman, and frankly, overkill for our purposes. Substitute? Mineral spirits. I don't have a funnel small enough, but I do have this big syringe. Wait, single use only. Is this for medical applications? Can any nurses out there tell me why the f*** you would need such a big... Sealed for freshness. Yep, that's fresh. So I took 300 mils out, so I'm using 300 mils of mineral spirits to flush it. I base that logic, of course, on absolutely nothing. Fun fact, the guy who sang that song is as white as I am. True story. Why isn't this draining? Ah, there we go. Gotta get it up on the corner there, folks. Go ahead and replace with the correct volume of the much more benign and pleasant smelling, but just as lubricious, air compressor oil. If you Google the compressor model number, it's on the top there, you can usually find the oil capacity. For this Copeland, I got bupkis, and that's why I measured the oil that came out, in my case at 300 mils. That way you know what the answer is, just in case. You have to pour real slowly like this, because it takes a second for the oil to drain and fill the bottom, and if you go too fast, it'll... God damn it. Nice and slow. The second oil-related challenge is keeping the new oil from burping out of the discharge port as it runs. And that's an easy one too. You just need a cheapo oil separator. $6 at Harbor Freight. Cut off the discharge line with a tubing cutter. Again, it's the skinnier one of the two that don't end in a service port. HVAC lines are all sized by the outside diameter, unlike plumbing copper. This one happens to be 1/4 inch, and hopefully yours is too, because this 1/4 inch flare nut from Home Depot fits right on. If you've never flared before, you just need a cheap flaring block like this. Just clamp it on the appropriate size. If you'll notice, this says 3/16. That's because this is for plumbing copper, which is measured by inside diameters. So add 1/16 to the plumbing size, and you get the HVAC size. Fun bit of trivia for your next Tinder date. Hook your flaring tool onto the block, and tighten it down until the tip of the cone is touching the outside of your copper pipe, which should be sticking out just a little bit. Take the tool off. Undo your flaring block. And you've got yourself a nice flared fitting. Go on and get yourself 3 of these flare unions from Home Depot too. One side fits the flared end you just made, and the other threads into the female inlet on your oil separator. I know. There's no point in sealing the threads on a flared fitting. It's not how they work. But I'm superstitious, please leave me alone. There. Now we can thread in the oil separator. Because both the inlet and my flare adapter are both male, I'll need a 1/4 inch coupling. Home Depot again. Onto the outlet. A second one of these flare adapters. Whoops, forgot my dope. Yeah, it's a bit Rube Goldberg. I'm sure it could be simplified, but hey, it works. Let's get the compressor off the workbench and get this assembly prepped for transplant. I'm going to remove all the unnecessary stuff, namely the condenser fan, the condenser, and the filter dryer. The electrical box is going to stay, along with all the wiring. This particular fridge does have a pressure switch on the hot wire, which I'm just going to have to jumper out. Cut and splice. That should leave plenty of room on the plate here for activities. Compressor back on. Reinstall the wiring to the face of the compressor. Quick function test. Good to go. Next up is to get this motor out of here. But first, let's identify our wires. Ground goes to the chassis, which is good. We'll leave that there. The hot line goes through the power switch, which we'll keep, then through this fuse, which we won't, then to this pressure switch, through... Is that a bridge rectifier? What? The neutral is also going to it. Why would you put a bridge rectifier on an AC compressor motor? Unless this is some sort of cheapo DC motor? There's no DC components on here otherwise. I mean, that's what a bridge rectifier does. It converts an AC waveform into DC. It's a mystery to me, but rather than solve it, I think I'll just remove all of it. Metric pipe fittings. When will China get with the program and adopt inches and fractions like we do here in America? It's clearly the better system. I mean, who wants to count? That's boring. Damn, thread locker. Nice job, Harbor Freight. Just gonna cut out all wires going to the bridge rectifier. Whoop, missed a zip tie. Where are my damn cutters? Always! Oh, hello. Let's talk about current ratings. According to the datasheet, this pressure switch can handle 15 amps, no sweat. The switch is good for 16, so that's sufficient too. The fuse is rated for 3, so that's gone. The power cord is 16 gauge, which at this length is going to be underrated. But since current capacity of a wire is based on its gauge and length, I'm just going to cut it in half in lieu of sourcing a heavier duty cord. I'll get a longer cord someday, or just a longer air hose. Here's my wiring setup. It's really simple. The compressor's OG power cord comes in, it's grounded at the factory spot, along with its new roommate, the ground wire going to the refrigerator's cap box. The power cord's neutral goes right to the cap box's neutral, and the hot wire goes to the power switch, skips the fuse holder, and goes straight down to the pressure switch. From there, the juice gets fed down to the line wire on the cap box. Does it work? Let's find out. And yes, you should tidy up your wiring with some conduit. You're in the shop after all. Stuff happens. Now to find a way to plumb the discharge from the compressor onto the Chinesium check valve. I want to use 1/4-inch flare fittings, but the check valve is metric. M10 by 1.0 to be precise. Just need to find some pipe fitting of some sort that we can drill and tap to fit. I've got a third Home Depot union here. I wonder. According to Professor Google, to tap an M10 by 1 hole, you should start with a 9mm hole. I'll take it. I can just ream it, tap it, and boom, instant M10 to 1/4-inch flare adapter. If none of your bits are metric, 23/64 worked great for me. It's almost as if I knew what I was doing. I don't. What's the difference between a machinist and a schlub with a Harbor Freight mini milling machine? Whatever, it'll seal. The nice thing about using 1/4-inch flare is you can get an air hose or an old HVAC service hose like this for cheap. 1/4-inch flare fittings, pre-installed. There we go. Frankly, this could be your permanent setup if you wanted to. I mean, the hoses are going to snag and they're not going to last as long as a hard line. However, the burst pressure is phenomenal. Balderdash! My precision machine fitting leaks. Who could have seen that coming? This paste works great for vacuum lines, water lines, and fuel lines. But for air lines, better off going old school. Let's try again. Any improvement in the noise department is null and void. Seems to be coming from the check valve. Must not be able to handle the increased flow. Still, let's see if it works. Oh, forget it, I give up. That's even worse than the original sound. Fun fact, refrigeration compressors have built-in one-way reed valves, so you don't technically even need a check valve. My advice? Pop that useless rubber stopper out, and your check valve is now a metric straight-through threaded nipple. That's spring. Well, that's 60 seconds of my life back. I've made this hard line out of scrap tubing scavenged from the same fridge, so that's free. Just flared the end and put on some flare nuts. Professionalism. I think I'm going to shorten this shelf here. I thought about mounting the compressor on top of the tank, but these things have a ton of cast iron in them, so if this lightest breeze, it's going to fall over. I'm going to remount the electrical box there instead. And while I've got the grinder out and the safety squints engaged, I'm going to cut a hole in the shelf here for easier access to the pisser. And looking back, I'm not such a huge fan of the wiring. Too many hangly-danglies flopping around to catch and snag and rip on various workshop hazards. I'm going to consolidate everything inside the box, for safety. I'm running the power cord straight into the box, which happens to have convenient half-inch knockouts for strain relief. So all the grounds are tied together and grounded to the box. The neutrals are all tied together, and the hot will run in series through a basic panel-mounted toggle switch, then through the pressure switch, and then to the start cap as per the factory diagram. All joints are soldered and heat shrink tubinged. Much better. To filter the air coming in, a simple fuel filter and some fuel hose shoved into the suction port. How obvious is it that my attention span for this project is rapidly waning? And I put it on a dolly, one for easier water draining, and also for the sake of me old bones. Fridge compressors are heavy as shit. So that's it. Let me know if you have any other ideas, suggestions, room for improvement. I would have been happier with a beefier compressor, but it was free. It's still faster, more durable, and it's so quiet I can do this voice recording with it running. It's perfect for the apartment dweller or basement tinkerer who doesn't want his neighbors to hear this at 1 in the morning. Thanks for watching.